Okay, class, we have a new type of problem in here, very similar to like a test question, where we are going to use this clue that these two quadrilaterals are similar, and our goal is to find x and y, the values of x and y. This is pretty common. So what I've done ahead of time and what I recommend you do is buy into the color. I'm telling you, these pictures are going to be twisted, and turned, and flipped upside down. And it's much, much easier if you can read a similarity statement and understand what angles are matching up and what sides are matching up as you write these proportions here in order to solve for these sides. So how do we tackle a problem like this? The first thing we need to look for is sort of like a crutch. What is a crutch? A crutch is discovering two matching sides where you know everything about those sides. Now, notice those are the only two sides I know everything about. I know this light blue one is 9, the other one is 6. And the green sides, for example, shoot, I don't know anything about those. The brown orange color in here, well, I know 12, but I don't know that side. And the yellow team, notice I know 10, but not X. So I chose to write 9 over 6 because that's going to be my key to unlock all of the values to the other sides. So I wrote the bigger shape over the smaller one, 9 over X. And that's matching up to X all over 10. How do I know they're matching? Well, I color coded them. These, this is a ratio, and that's a ratio, and I know they're congruent. I know they're congruent because similarity says their sides are proportional. So 9 over 6 is congruent to or equal to x over 10. Well, what did we learn last section? Well, we learned how to solve for proportions like this. So this is going to be 6 times x is 6x, 9 times 10 is 90, and I think this is 6. Excuse me, that's not 6. How many times does 90 divided by 6? I think it's 15 maybe. Yes, 15. So I just used my calculator and I found the value of x to be 15. Well, the only other goal here is to find y. And once again, I'm going to use my crutch. My crutch is, whoops, my crutch is 9 over 6. And that's going to be proportional to 12 all over 3y minus 1. I'm using 12 and 3y minus 1 because they correspond to each other. And be sensitive. If you choose to do the 9 first over the 6, then you have to use the 12 first over the 3y minus 1. There's nothing wrong with writing the 6 first over 9, but then you have to write the 3y minus 1 over 12. So order here becomes very important. Both of these setups will work in order to solve for this, but I'm going to erase this one and use the top one. So what do we have in here? Well, 12 times 6 is 72. And now we learned last class that, look, 9 times this, so I'm going to use distributive property, that's 27y minus 9. I bring the 9 on the other side, that's 81 equals 27y. I divide both sides by 27. Y turns out to be 3. So don't let the algebra get in the way of you solving for this. The hardest part is understanding why we are allowed to set one ratio equal to another. That's all because of similarity. All right, we just got a few more problems left.